In this video, which is part 4 of our review of the 5th grade curriculum, we're going to begin to work on fractions. And if you look at our list here, the first topic is writing fractions in lowest terms. So let's talk about how we do that. Another way to say, to put a fraction into its lowest terms is to say that we're going to reduce it. So how do we reduce a fraction? Let me give you an example. If I said that a class has 10 students and 5 out of those students play hockey. Okay. Must be good athletes if they can play hockey. Very demanding game. If 5 out of the 10 play hockey, I can make a fraction that indicates that. Okay, 5 out of the 10. Another way for me to say that, however, would be that half of them play hockey. Okay, intuitively we know that 5 out of 10 is half the class. But how do we get there mathematically? How do we prove that using math, that these two fractions are equal, that they have the same value? Folks, this is how you do it. You look for a number that you can divide the numerator by and the denominator by to get you to the new fraction, smaller fraction. Okay, since we're dividing, we know the numbers are going to get smaller, like we talked about in earlier videos. So what number do we know can divide into 5 and 10? It is none other than 5. So you divide 5 by 5, you get 1. You divide 10 by 5, you get 2, and now you have reduced the fraction. Now, the question is, can we go any lower than 1 over 2? And the answer is no. This is as low as we can go. So the whole key to this video is to find this green number. Find a number. Has to be the same number that you use on the numerator and the denominator to get you to a smaller whole number. As we move through the video, that's what we're going to do. We're going to identify the green number. Let's look at this fraction here and talk about how to reduce it. We need to find a number that divides into 6 and into 8 evenly. The first thing I notice is that they're both even numbers. And when you have even numbers, I suggest you try 2 as your green number. If we do that, 6 divided by 2 is going to give us 3. 8 divided by 2 is going to give us 4. The question is, can we go any lower? Is there a number that we can divide both of these into? And the answer is no. This is the end of the ball game. All right, we don't bother with 1. Okay, I understand that we can divide both of them by 1, but that just gets you where you started. So this is an exercise in futility. It really doesn't help us. 3 out of 4 is the end of the ball game. Notice, folks, that 3 is a prime number. Usually when you have a prime number, that's usually the end of the ball game, but not always. Let's do another one. What is 6 over 10 in lowest terms? 2 even numbers. What green number are you going to try first? None other than 2. It's going to give us 3 over 5. Because look, 6 divided by 2 is 3. 10 divided by 2 is 5. If you want to check yourself, which I often have my students do in my classes, I have you go the opposite way and use multiplication. 3 times 2 indeed gives you 6. 5 times 2, let me just put a times here, gives you 10. This is the smallest we can go. 3 and 5 are prime numbers. Let's do another one. 16 out of 36. 2 even numbers. I'm going to try green, number 2. 8 divided by 2 is going to give us, I'm sorry, 16 divided by 2 is going to give us 8. 36 divided by 2, if you're not sure what that is, come down here and do a little miniature division problem. There's nothing wrong with that. Here's 36 divided by 2. We drop 36 into the box. Sorry, I should have done this in a different color. How many times does 2 go into 3? Once. Bring down the 6 and 8. So 36 divided by 2 is going to give us 18. Now, are we done here, or can we get smaller? We have 2 even numbers still. Let's see if we can get smaller using 2 as our green number again. Doesn't have to be 2. We can use another green number at this stage. In other words, this green number does not have to stay the same as you get to smaller and smaller versions of the original fraction, and we will see that in subsequent examples. Folks, what is 8 divided by 2? None other than 4. 18 divided by 2 is 9. End of the ballgame. There is no other number that we can use to make this smaller. For example, if we tried to use 2, because 4 is even, as our green number, we would not be able to use it here. Okay. Let's move on. So far we've only spoken about even numbers. How about a number like this? Here we have an even number, so our instinct would be to try the green number of 2. Yes, 6 divided by 2 will give us 3, but you can't divide 9 by 2. When you have an odd number, folks, try 3. So let's do 9 divided by 3. That's going to give us 3. 6 divided by 3 is going to give us 2. Final answer. Can't get any smaller than this. Odd numbers. 2 won't work. Let's try 3. This works. 15 divided by 3 is 5. 21 divided by 3 is 7. We have 2 prime numbers. I want to emphasize that 6/9 equals that 2/3. They are the same value. 15 over 21 equals 5 over 7. Can't get any smaller. 2 prime numbers. End of the ballgame. How about this one? As soon as you see that odd number, 9, try 3. It works. Top and bottom. 9 divided by 3 is going to give us 3. 21 divided by 3 is going to give us 7. Let's keep going. How about this one? Folks, whenever you have a 0 after a number, or a 5, I'm going to do these together. A 0 or a 5 is always divisible by 5. When you see a 0 or a 5, 5 becomes your green number. Ten divided by 5 is going to give us 2. 20 divided by 5 is going to give us 4. Are we done here, folks? Answer no. 2 even numbers. We can get smaller. What number do we try first when we have even numbers? None other than 2 is our green number. This brings us to 1/2. 4 divided by 2 is 2. 2 divided by 2 is 1. Look, we used a different green number as we went from the original fraction to the final reduced fraction. That's okay. If I told you 10 out of 20 students in a class played hockey, you would tell me that's half the class. This is the math that proves it. Let's see what's going on down here. See that 5? I know it's going to be divisible by 5. See the 0 in the number 20? I know that's going to be divisible by 5. Let's see where this takes us. 15 divided by 5 is 3. 20 divided by 5 is 4. If you wanted to check your math, 3 times 5 gives you 15. 4 times 5 gives you 20. That's your reduced fraction. We cannot go any further. How about this one? What jumps out at you here? One of them ends in a 5, one of them ends in a 0. Therefore, by definition, what can we use as a green number for both of them? None other than 5. 35 divided by 5, we know that to be 7. What's 90 divided by 5? Folks, no one expects you to know that. So you come over here and you do a small little division problem. This is 90 divided by 5. We're going to put 90 in the box. How many times does 5 go into 9? Once. I'm sorry, I ran out of room. So does that go up a little bit? Yeah, a little bit. 9 minus 5 is 4. Bring down the 0. How many times does 5 go into 48? So 18 times 5 will give you 90. 7 times 5 gives you 35. 5 works when you have a 5 or a 0 in your original number. Can we get any smaller here from 7/18? No. 7's a prime number. Prime numbers usually mean the end of the ball game. Okay. How about this one? What have we learned so far? We've learned, let's do this in a different color. If you have 2 even numbers, your green number that you want to try is 2. We've learned that if you have 2 odd numbers, the green number you want to try is 3. We've learned that if you have a number that ends in 0 or 5, the green number you're going to use is 5. What if you have a fraction where none of these work? How about this one? First instinct, 2 even numbers, is to use 2 as your green number. Let's do that. Folks, no one expects you to know off the top of your head what 56 divided by 2 is. So what do? We do a small division problem down here. We put 56 into the box. We do our division. And we find that 56 divided by 2 gives us 28. We have 98 divided by 2. No one expects you to know that off the top of your head. We're going to do a division problem. 98 divided by 2. We're going to put 98 in the box. 2 goes into 9 4 times. 2 goes into 18 9 times. 2 times 28 is 56. 2 times 49 is 98. Okay, now what do? Let's move this over a little bit. Give ourselves some room. Okay. We have an even number. We could try 2, but 2 does not go into 49 because 49 is odd. We have an odd number down here, so we could try 3, but 3 doesn't go into 49. 5, forget about it. It has to end in 0 or 5. So now what do? Let's pick a larger green number, one we haven't tried yet. How about 7? Remember, it has to be the same number. Can you divide 28 by 7? Yeah. You get 4. Can you divide 49 by 7? Yes. You get 7. Whenever you see 49 in your fraction, think about 7 times 7 and see if 7 goes into the other number. Here's another one. 21's an odd number. First number you think of when you see an odd number is using 3 as your green number. Does 3 work? No, because 3 does not divide into 49. 49, when you see 49, folks, I want you to think about 7 as your green number. Does this work? Yes. Can we get any smaller than this? Answer no. Both prime numbers. Usually prime numbers mean the end of the ballgame. Okay, folks, I'm going to end up with just some examples. I'm going to mix in odd, even, etc. See how you do. Feel free to pause the video. The immediate reaction you should have when you see 5s and 0s is to pick 5 as your green number. We don't expect you to know what 55 divided by 5 is off the top of your head, or 80 divided by 5 is off the top of your head. You need to do small division problems on the side. "55 divided by 5, you might know that one. So I'm going to go ahead and put that down. 11 over 16, can we get any smaller? Answer no, we have a prime number here, 11. Usually, prime number means end of the ballgame, not always. You got to investigate. How about this one? Folks, you have even numbers. You have even numbers. 2 becomes the star. Are we done? Answer no. We can get smaller. We have 2 even numbers. Sorry. I want to stick with green. Remember, you have to use the same number on the top and the bottom. Are we done yet? We have an odd number and an even number. Can we get any smaller here? We have a prime number. But can we get smaller? Yes. Okay, if you have 12 hockey players out of 24 students, it's the same as 1/2. So what did we learn here? Prime number does not always mean the end of the ballgame. If you have an odd and an even number, try 3. We could have tried 2, because this is an even number. We might have tried 2, but 2 cannot be divided into 3 evenly. A couple more. Two even numbers. Who's the star of the show with even numbers? 2. 36 divided by 2 is 18. 40 divided by 2 is 20. Are we done? I don't think so. 18 divided by 2 is 9. 20 divided by 2 is 10. Now we're done. Can't get any smaller.